So what we have done so far is we have did the factoring using the sum and product method if you have a trinomial and you are looking to find the factors. Now, what if I have a binomial? What if I have two terms and there is quadratic term? Okay, how can I factor this? So remember that in the case of trinomial where you had y equals, let's say, x squared plus 5x plus 6, you looked for two numbers that multiply to 6 and add to 5, right? So that was easy. What if I have something that looks like this? Y equals x squared minus 49. So in this case, as you can see, I only have two terms. It's still quadratic because I have a degree 2. So this is still part of the quadratic. It's just, it has only two terms. So the middle term is missing. This is a special case, and we call this case the difference of squares. All right, so why do we call it the difference of squares? So we call it difference of squares. Number one, difference means subtraction. So I have a subtraction of two square terms. Okay, so difference of two square terms. So if you look at your first term is x squared. So it's a term that has a square on. The second term, which is 49, is actually a number squared, and it's 7 squared. So there's these special, like the perfect square numbers. So if I do 1 square, I get 1. 2 squared, 4. 3 squared, 9. 4 squared, 16. You should be able to recognize these numbers. Okay, 5 squared, 25. 6 squared, 36. 7 squared, 49, and so on and so forth. Okay, how do you know that a term is square? If you actually square root that term and you get a whole number, it's a perfect square. Okay, so this is what you're looking at. You're looking at two terms. They're both square terms with a negative in between. This is how we define difference of squares. All right, now if I'm looking at difference of squares, how can I factor that? So let me just clear this. So I'm looking at difference of squares. How can I factor them? So to factor difference of squares, you're gonna start with opening two brackets. In the first bracket, you're gonna put a plus in the middle. In the second bracket, you're gonna put a minus. In the first position of each bracket, you're gonna put the square root of the first term. So in this case, it's gonna be the square root of x squared. And then in the second position, you're gonna put the square root of the second term. So it's gonna be the square root of 49, which is going to give me square root of x squared is x plus square root of 49 is 7, and then x minus 7. You can skip that step if you want, as long as you know what you're doing in your head is that's what's happening. So you're taking the square root of the first term and then the square root of the second term, and then one bracket is going to be a plus and the other bracket is going to be a minus. Now, let's see if that actually works. So if I expand this, would I get x squared minus 49? Let's see. So if I expand this, I'm going to write it on a different color. If I FOIL, that's going to be x squared minus 7x plus 7x minus 49. So what happened here is you have x squared minus 7x plus 7x, they cancel each other, and that's a 0x, so I don't write that. And then minus 49, right? So having that plus and minus is going to cancel your middle terms, and then you're going to end up with difference of squares. Okay, so remember, a difference of squares is going to be two term, and then the first term is going to be a square term, the second term is going to be a square term, and then you're going to have a minus between them. And to factor this, you open two brackets, you take the square root of the first term, which is in this case a, put a plus and minus, and then take the square root of the second term, which in this case is b, and that would be a squared minus b squared is equal to a minus b times a plus b. All right, so these are your difference of squares factor. Okay, you should be able to recognize this. So for example, if I have y equals 4x x squared minus 9y squared, for example, I realize that I have two terms. They're both square terms and there is a minus between them. So I can factor, I have a plus and minus. The square root of the first term, that's going to be 2x. So I'll put it in the first position. The square root of the second term, it's going to be 3y. I put it in the second position, and that is my factored form. All right. Now, the other one that you also probably, it's going to be helpful to know this, is factoring perfect squares. Okay. Now, if you don't remember, this one specifically can still use the sum and product to do it. But then what this is, it's basically whenever your factor ends up being the same. So let's say if your factor is when you do the product and the sum, and then you end up with like 3 and 3, right? And then that means you're going to end up with x plus 3 times x plus 3. But instead of writing it this way, we write it as x plus 3 squared. We call this the perfect square. Okay, so how do I recognize this? So I'm looking at x squared minus 12x plus 36. So if you look at your first term, it's a squared term. If you look at your last term, it's a squared term, right? So remember your squared term, 1, 4, 9, 16, 25, 36. 36 is a squared term. And then you're going to look at your middle term. Your middle term is going to be twice as much as your last term. Okay, so since both x squared and 36 are perfect square, we should first try the -6 and -6 as the two numbers we are looking for. So if I'm looking for a sum and product here, product of 36 and a sum of -12. Because 36 is a perfect square, I have to think about what multiplies 36. So we know it's 6 and 6. It's going to be -6 and -6. And that adds to -12. So I know right away that my factor is going to be x minus 6 squared. So that's going to be my factor. Okay. If you don't remember this one specifically, you can always do the sum and product and test differently. So you can have like -12 and -1. It's going to be -13. You can have the -3 and -4, and that's going to equal to -7. So you know this is not it, this is not it, and it's going to be okay. But it's always nice to recognize the perfect square and then be able to factor it right away. Remember, with a perfect square, if you have, let's say, x squared plus 12x plus 36, your factor is going to be x plus 6 squared, because this term is a positive term, so that means it's going to be positive here. If you have a negative in your middle term, then your this is going to be also a negative. Okay. Let me look at another one. So let's say if I have x squared plus 14x plus 49, I look at these numbers. This is a square term, 49 is a square term. So I'm going to try 7 and 7. 7 and 7, they add to 14, so they add to the middle term. Here we go, right? So right away I can say it's x plus 7 squared. Okay. Okay, so these are 3 different kinds of factoring. So perfect square, again, you can use sum and product. It's the same thing. It's just a special case of it. And then difference of squares is a little bit different because there's a formula that you have to follow. And remember, we use that when you have a binomial, square terms. So a square and a square with a subtraction between them. All right.